Hello everyone, welcome back to my channel. I'm Tepin and this is the second part of second lesson following our previous analysis, and from here we will start to calibrate our data and we will do the further analysis. So let's get started. And now we're going to calibrate. You can choose most recent common ancestor priors. First we're going to calibrate based on the oldest most common ancestor, and in my dataset is based on the divergence of Basidiomycota. So in here I have all these species from Basidiomycota except one, that is Neurospora carasa. This is Escomycota. So first what I'm going to do is estimate the divergence between Escomycota and Basidiomycota and the family within them, and then I'm going to estimate the divergence of Hymenocetaceae based on the fossil and the genera within them. So this is what I'm trying to do here using the beast. So we're going to go here, and I know that Astilego maris is the oldest, or you can say one of the earliest Basidiomycota. So I'm going to put this here, and this is the Scomycota, and put anything here like Esco Basidio. This is the we're going to use the fossil that represent the divergence between these two. So we're going to press OK, and here we have, and in order to estimate divergence we have to distribute it also. I mean distribute it within the time. So we can use normal distribution or any type of distribution. Just for understanding, I'm going to show you a PDF. You can see uniform distribution. So for example, this is the point of time where you want to estimate, where you are estimating this is the, for example, the 400 million years old. This fossil may be uniformly distributed from 400 to more or 400 to less. So this is what uniform mean. And for normal, you can see the graph here, maximum in the point where you want the node, or as it go to the either end, the probability decreases like that. And all type of distribution, how they behave is given here. We're going to just use, we can use uniform also because we don't know exactly. So we can use uniform, and the range is early Devonian, that is 419.2 to 393.3. 419.2 to 393. 393.3. So this is the type of estimation that we're going to do, and you can also choose other type of distribution. And we're going to use another which represents the family Hymenocetaceae, and I know all of the species within Hymenocetaceae are, these are the species within the Hymenocetaceae. I'm going to mark them all and keep them here, and Hymeno. Okay, press. So you want to estimate this also, use this one. There is from 121 to 129. Let's just estimate it as 121, from 121 to 129 million years ago. Because it is fluctuating here and here, so I'm just going to take the minimum and the maximum. And same, we're going to use uniform here because we don't know the exact, so we'll give the probability to all the range. If you want to give the probability to the mean, then you can do this. Let's just give it this. So we have to take the mean value. Okay, 125, that's 125 mean value, and we want to estimate between 121 to 129. We can take 3. No, it is too much. 2. Yes, 121 to 129. We can take this. 2 is enough. And close this. And now, based on the size of your dataset, this chain length may vary. So my dataset is quite big. I know there's only 30 taxon, but the sequence size is quite big. It is almost around 6,161 sequence long. So it is based on this you have to sample more. So I have done many previous trials and I came to know that it works better at least at 20 million. 20 million generation is good enough. You have to, run few times. Like for example, you can run 1 million, 5 million, 10 million, each of them few times and estimate them. And how we are going to estimate that, we will look into the tracer that we are going to do after this. So you can now save the file. Let's just save a new file, new folder. You can save it as escobesidio Mino divergence and save it. So we have just generated an XML file. Now we're going to load this in the Beast. You just open Beast, and here you have to also do one thing, that is Beagle info. Click here, just click here. If you have installed Beagle, and I forgot to mention that you have to also download Beagle, you can download it from also Google. Just search it in the Google, Beagle 4.0. You can then install it. You don't have to do anything, just install it. And then after you run Beast, just press here once. If you see like this, then you have Beagle here. It will increase the speed of your analysis. Like for example, if the analysis is going to take 10 hours, then it will reduce it to like 7-8 hours, like that. So you can open Beast and select the file from here. Just open it, choose your thread. My PC can go up to 8, and then just press run. So this is it for this lesson, and in the next lesson we are going to analyze the Beast output using tracer and do further analysis. And thanks for watching. See you in the next lesson.